Hello guys, and hi, welcome back to my channel. So today we are going to discuss about a very simple basic differential equation question. So this is about radioactive the rate of decay of the radioactive substance. So initially, okay, there are 20 gram of radioactive substance, so 20 gram. So the time taken for the amount to decay to 10 gram is 6 seconds. So originally it is, I denoted as R0 is 20 gram, and then it will decay into 10 gram. So 10 gram is half of it. Okay, R equals to 10 gram, so this is half of it. So it takes time T equals to 6 seconds. So this T, because it changes from 20 gram to 10 gram, I mean it decays from 20 to 10, which means half of it. This T is represented by T half-life, okay, half-life T. Hence, the rate of decay of the radioactive substance is proportional to the amount present R at time T seconds is given by dr dt equals to negative kr, and K is the constant. So find the expression for the amount of R at any time. Okay, so we need to find R in terms of T basically. So let's write the equation. Okay, so you see there is a minus sign there indicating that the rate of decay, the amount of substance are decreasing over time. All right, so first we need to do the separation of variable. So we separate this R to the dr side, and then this T to this right hand side like this. So dr, so we divide by R, so we basically move this to the left side, and then negative k with times with dt, so we basically move this to the right hand side. All right, so like that. Okay, so we can differentiate this very easy, but I want to differentiate from R0 to R, and then from t equals to 0 to time t. Okay, so differentiate it, we get what? Okay, so 1 over R, the R integration is ln R, so we plug in from R to R0, so negative kt from t is 0 to t. Right, so we have this very beautiful expression. So ln R minus ln R0, like that, equals to negative kt. So this is what ln R divided by R0, so we can use the properties of logarithm, negative kt, and then we can raise e to the both side, e, then we get R equals to R0 e to the minus kt. So we multiply both sides R0, okay, after we raise e, after we eliminate the ln from the left hand side, okay, by raising it to the e. Okay, so it's so this is R0. Then we can find the value of K, okay, using this information. Okay, so because we know that R is 10, R0 is 20, E minus K, T is, it occurs at 6 seconds. Okay, so just find the value of T, or like this, maybe this is wait, alright, so maybe we don't have to raise both sides by E, instead we can do like this. Okay, So this is not a good way of doing. So first we ln r divided by r naught is negative kt. Because we know that r is 10, r naught is 20, so this is negative k, so t is 6. So we find k is negative ln half. So because 10 divided by 20 is 1 half, then all divided by 6. So this is basically ln 2 divided by 6, right? So this is the expression ln 2 divided by 6. So you can find the decimal equivalent value for this, but I will leave it like that. Okay, so like that. So because we already know the value of k and we know that r naught is 20, and then from what? From here, so we can raise e to the both sides. So e like this. Okay, to be more convenience, I just raise by e like that. Then you have, so the e and the ln will cancel, so we have r over r naught e to the minus kt. So r naught I will move it to the right hand side, r naught like that. So r naught is 20, just plug in the value. E to the minus k is ln 2 divided by 6 t. So at any time t, you will find the value of r, or the amount of the radioactive substance at certain amount of time. Okay, so let's proceed into the second question. So prove that the time taken for the amount to decay to 5 gram is 12 seconds. So we want to prove, so we know that r naught, so the original value of r is how much? 20 gram. So r naught is 20 gram, don't forget that. And we at r equals to how much? 5 gram. We want to prove it occurs at t equals to 6 seconds. Is it 6? 12. Sorry, it's 12. Yeah, so it's 12. Okay, so we just use the previous formula that we find that one. So r is 20 e to the minus ln 2 divided by, ln 2 divided by 6 times t. So r is 5, 20 e to the minus ln 2 divided by 6 times t. So we want to find the value of t here. What is t? So let's find. So let's divide both sides by 20. So 5 over 20 e to the minus ln 2 over 6 times t. So let's ln both sides. So ln both sides. So the e will cancel. So ln 5 over 20. So the e will cancel. So it will leave us with ln 2 divided by 6 times t. Hence t is ln 5 over 20 divided by negative, so I will put a negative here, negative ln 2 over 6. Okay, so this will be equivalent to, I will move the 6 to the top of the fraction, so it will be 6 times ln 5 over 20 over ln 2. So let me grab my calculator to confirm, which it indeed to be 12. Let me find my calculator first. And then I already plug in the values into my calculator and I get it is indeed 12 seconds. Hence, because from the given question, it wants us to prove that the time taken for the amount to decay to 5 gram is 12 seconds, then indeed we get it is 12 particularly. Hence, this is the correct answer that we want proven. Right? Yeah, so that's all. So it is very easy and very doable. I hope you can understand my explanation and the approach that I did, and that's all. Thank you.